everyone, my name is Niet and welcome from our documentation program ChemiTalk. For today, our program is about conducting a batch pack distillation experiment, the importance and the objective of this experiment. Currently, I'm now at the University Technology Petronas to have an interview session with the three most important persons in chemical industries field. Before I interview to the invited guests, let me explain briefly about this experiment. Distillation is the most common type of separation process used in chemical process industries. The mixture of liquid is heated to form the components at the different boiling points in the gas phase, and then gas phase is condensed back into the liquid and it is collected. For this experiment, there are two sub-experiments, batch distillation at the total reflux and the batch distillation at the constant reflux. So what are the differences between these two? Stay tuned for more information about the experiment and let us interview the invited guests in the lab right now. First of all, we have our invited guest, Professor Derricks, to explain about the application of the experiment. Hello, Professor Derricks. Professor Derricks, can you explain about the application of batch distillation in industries?
Well, the application of batch distillation on the industrial scale can be found in petroleum refineries, petrochemical plants, pharmaceuticals, and you know, of all these, distillation is very prominent in the pharmaceutical industry.
Professor Derricks, now can you briefly explain how ethanol is used to produce pharmaceutical products?
First of all, the production of ethanol begins from the fermentation process, where sugar contents in organic materials such as in juices or sugar canes are catalyzed by introducing yeast or enzymes. After the fermentation process, it undergoes a series of other processes such as scrubbing, distillation and purification. Lastly, solvents, which are chemical substances, are added into it so that they provide molecule to build some drugs for the pharmaceutical industry.
Now, Professor Derricks, can you explain about how does the pharmaceutical product be beneficial to the people?
These pharmaceutical products, such as the ones found in medicine, like for example in penicillin, aspirin and cough syrup, are very important in the healthcare sector. Besides that, with the advancement of technology, this pharmaceutical product has even been used to treat skin problems.
As you can observe here, this is the process of preparing mixture of ethanol and water to prepare the refractive index versus composition plot. Then over here, we have a refractometer which is used to calculate the refractive index of each ethanol and water mixture that have been prepared earlier. After distillation has taken place for a time interval of 15 minutes, samples from the bottom product and distillate was collected. Over here, we can see how the bottom sample was collected. And over here, we can see how the distillate sample was collected. And then finally, temperature for both the bottom and distillate product is recorded from the control panel shown here.
Now we have Ms. Lee Xiying, who is the process engineer of the distillation unit. Nice to meet you, Ms. Lee.
Nice to meet you, Mia, too. I'm Xiying. I'm the process engineer of the batch pack distillation column. So, hi to the audience in front of the TVs also.
Without any delay, let us go to the topic of results and discussion of the experiment. So, Ms. Lee, is there any preparation needed for the experiment?
Yes, before the real experiment started, we need to prepare a calibration curve of ethanol water mixtures. Before that, we will prepare a mixture of ethanol water mixture with different composition, and then the refractive index of the mixture is being measured by using the refractometers. After the value is being obtained, a graph of refractive index versus the mole fraction of the ethanol will be plotted for the further use of the experiments.
Now, Ms. Lee, can you briefly explain how to use the calibration curve?
Sure. After the ethanol is being obtained from the top and the bottom of the batch pack distillation column, the refractive index is being measured. Then, this calibration curve is being used to obtain the mole fraction of the ethanol. Another way of using this calibration curve is to draw a best fit line, and a linear equation is being obtained, which is y equal to 0.0243x plus 1.3453, where the y is refractive index and the x is the mole fraction of ethanol. Then, by substituting the value of refractive index inside this equation, the mole fraction of the ethanol can be calculated.
Thank you, Ms. Lee. Now we would like to proceed to the experiment A that is being conducted. So what is experiment A about?
Experiment A was being carried out at the total reflux condition where there are 0 products flow out at the top of the batch pack distillation column. All the distillate is being recycled back into the column. In this experiment, we will vary the heater powers, which was set at 100, 80, 60, 40, and 20%. After that, the mole fraction of the ethanol is being measured by using the calibration curve that was being developed from the previous experiment. Next, by using the Metcalfe-Taylor method, the number of theoretical plates required to obtain the same separation as the column is being obtained. The objectives of this experiment is to determine the height equivalent theoretical plates, which in short is HETP at the total reflux conditions, which indicates the efficiency of the distillation column. HETP is defined as the effective height of the column divided by the number of theoretical stages. Theoretically, the higher the number of theoretical plates, the higher the efficiency of the batch pack distillation column. This means that lower HETP will result in a higher efficiencies column.
That's very interesting. How was the result obtained from the experiment? Can you briefly explain to us?
Yes, of course. The graph being shown here is the graph of the HETP of the column against the heater powers of the reboiler. As we can observe from the graph here, it shows a horizontal straight line which indicates that the HETP is the same for all the heating power, that is 560 mm. Therefore, we can conclude that the efficiency of the batch pack distillation column is not affected by the HETP. Thus, in this experiment, which is in the total reflux conditions, the minimum number of theoretical plates that is needed to carry out the desired separation is 2 for all the heating power.
So how will the changing of the heater power affect the experiment?
Okay, varying the heater power of this experiment will affect the mole fraction of the distillate and bottom products. When the heater power is being increased, the temperature supplied to the reboiler is also increased, which in turn increase the speed of the evaporation process of the ethanol. As a result, the increase in the temperature will shorten the duration of the distillation column as the ethanol will be evaporated faster. Besides, the higher heating power will cause a larger amount of ethanol being collected at the top of the column.
Thank you for the explanation, Ms. Lee. Now we would like to proceed to the experiment 2, where the experiment is carried out in the constant reflux condition. So what is constant reflux?
Under constant reflux condition, the instantaneous composition of the distillate is constantly changing because the composition of the more volatile components is continuously depleted at the bottom of the distillation column.
So how is the results of this experiment?
Okay, from the graph, the HETP is showing a decreasing trend From our research, we know that the number of theoretical stages is inversely proportional to the HETP. Thus, in this experiment, the number of theoretical stages is increasing with time. Theoretically, lower HETP and higher number of theoretical stages indicate that the distillation column will have a higher efficiency. Thus, we can conclude that the longer the time, the higher the efficiency of the batch pack distillation column.
So do you have anything to add on regarding the results of experiment 2?
Yes, from the graph of mole fraction of ethanol against time, we can see that the mole fraction of the distillate is increasing with time, which is indicated by the blue line, whereas the mole fraction of the bottom products is showing an opposite trend, which is decreasing, and it is indicated by the orange line. This proves that the purity of the ethanol being produced at the top of the distillation column is increases when time is increasing.
How about the moles of ethanol left in the reboiler?
Yes, we also calculate the moles of ethanol left in the reboiler, and a graph of moles of ethanol against time is being constructed. From the graph, we can conclude that the moles of ethanol in the reboiler is decreasing as time is increasing. This is due to when the temperature is increasing along with time, more ethanol will be evaporated and collected at the top of the distillation column as distillate. In contrast, the mole fraction of the bottom products will be decreasing with time. Last but not least, the percentage error is being calculated. The experimental value is the initial reboiler composition, which is 0.647, whereas the theoretical values is calculated from the equation FXF equal to dXd plus Bxp. As a result, the percentage error in this experiment is 40.43%.
Thank you, Ms. Lee Ziling, for explaining about the details of the whole experiment.
You're welcome.
Last but not least, we have our invited guest, Mr. Hafiz Ridwan, who is the safety engineer of the chemical industries. Hello, Mr. Hafiz. I have seen that the process involves ethanol. May I know what are the insights to handle this material safely?
Okay, so firstly we need to wear gloves, as ethanol is irritating to the skin if it is exposed in large amounts. Also, it is recommended to wear face mask because it is dangerous to inhale. And also to note is that we have to avoid sparks or flames because ethanol is highly flammable.
So what are the safety measures while conducting the experiment?
In the laboratory, it is recommended for any chemical engineers to wear lab coats, safety helmets, and also shoes whenever in vicinity of the laboratory.
Thank you, Mr. Hafiz. Now may I know what are the effects of improper use of ethanol in the industries like pharmaceutical industries?
In pharmaceutical industries, if ethanol is used in high doses within medicine, it can cause aggressive behavior, nausea, and also vomiting. So it is advisable to consult a physician because alcohol metabolism varies with age.
Hafiz, may I know what are the errors and recommendations of this experiment?
Okay, in this experiment, we use a refractometer. It is important to note that every time that you use the refractometer, to clean the refractometer after refractive index of each sample is calculated. Also to note that for every sample that we have collected from the distillation column, we have to close the vial tightly because ethanol evaporates quickly at room temperature. And also, it is important to note that every time we want to take the measurement of the liquid level, we have to make sure that our eyes are perpendicular to the liquid level to avoid parallax error.
Well, I'm sure all of you know the details about the batch pack distillation experiment. To recap what we have learned, there is a constant HETP in the total reflux experiment and a decrement trend in the HETP of the constant reflux experiment. Moreover, we have also learned about the applications, procedures, results and discussion, error recommendations. documentation, and last but not least, safety measures while conducting the experiment. I'm sure the invited guests explain clearly of what you are confused before you watch this program. Thank you for watching ChemiTalk and have a nice day. Bye.